Okay, so talking about these triangles. So today's our first day on this. We're talking about very basic stuff here. So again, a triangle, what does the prefix tri mean there? Three. So when you're talking about a triangle, you're literally talking about a shape that has three angles. A three-sided polygon. Now, when we name a triangle, we're just going to name it by its three vertices. So this right here, this triangle is going to be triangle WXY. Okay? Triangle WXY, just naming it by its three vertices. Okay? What are the three sides of this triangle?
X, Y, X.
Okay, side WX is one side. What's another one?
XY.
Side XY, and then the other side
YW.
is WY. Okay, WX, XY, and WY. Okay, now what are the three vertices of this triangle? Yeah, point W, point X, point Y. And then what are the three angles of this triangle?
Angle W, angle X, angle Y.
Okay, good. Angle W, angle X, and angle Y. Just simple, basic stuff there. Okay, now the next thing we want to do is talk about classifying by angles. Same stuff that we just talked about on our vocabulary. So what does it mean to be an acute triangle?
3 sides less than 90.
Okay, good. All the angles are less than 90. Okay, all of them are less than 90. Not just two of them, because that's a mistake a lot of people make. It's a common misconception. They look at a triangle and they see that it has two acute angles, and they say, well, that's an acute triangle. But then they don't look at the third angle, and the third angle is like 120 degrees or something like that. So be careful. On acute triangle, all of them have to be acute. All the angles have to be acute. Okay? Obtuse triangle. So what does it mean to be an obtuse triangle?
1 greater than 90.
Okay, it means it has one obtuse angle. All right, so like this. Has only one obtuse angle. And we talked about it. What is it whenever you have two obtuse angles? It's not possible, right? Because you get that right there, and you can't make a triangle out of that, so that doesn't work.
It's a bowl.
Yes, it turns into a bowl, not a triangle. Okay? Then what's a right triangle?
1 90-degree angle.
It's a triangle with one 90-degree angle, okay? With one 90-degree angle. So it's like this. And again, we talked about it. What is it when you have two right angles?
A cup.
Okay, you get a cup. You do not get a triangle. Can't make a triangle out of that. Okay? And then what does equiangular mean again? Okay, all the angles are the same measurement. And we talked about how big is each one of those angles going to be? 60. If they're all the same, and they all have to add up to 180, we'll talk more about that tomorrow, but if they all have to add up to 180, they've got to be 60 apiece.
So that means they have to be acute too, right?
Yes. So that's right. So an equilateral angle, equiangular will also be acute. Yes.
Hey, that's smart.
Pretty common sense, I think.
All right. So remember, this is classifying it by its angles. All four of those descriptions are by angles. Now we're going to talk about classifying it by its sides. So again, what does scalene mean? Okay, none are the same. None of them are the same length. So it's like this. Where this is one length, this side's different from the first one, and this third one is different than the first two. None of them are the same. Okay? What does isosceles mean? Two sides are the same. Okay? And then the third one is different. Okay, I know this is dumb, but I heard this a long time ago. In fact, I think one of my students came up with this, but this from a lot of years ago, but they said this. They heard it somewhere. I saw two leaves. Isosceles. I saw two leaves, not some. I saw two leaves. If you saw some, then that totally destroys the purpose of that. Isosceles. I saw two leaves. Two of them are the same. Okay, and then what does equilateral mean?
All.
Okay, all are the same. Okay, all are the same. And remember, if it's equilateral, it's also what?
Equiangular.
Yes. So
Means that it's acute.
these two, they're not the same thing. I mean, the descriptions are not describing the same thing. One's describing the angles, one's describing the sides. But if it's equiangular, it's also equilateral. If it's one, it's the other.
They'll have 60-degree angles too.
Yes, so if you have an equilateral triangle, that's exactly right. The angles will always be 60 degrees in there.
So this is one giant triangle if you think about it.
There you go.
There you go.
Kind of in some ways and kind of not in others. All right,
Jordan, you're doing too much.
so on the back.
Jordan, you're doing too much.
All right, so let's talk about this. Isosceles triangles. There's two isosceles triangles in this little figure right here.
Oh.
So name one of the isosceles triangles in there.
BED.
Okay, good. A, B, D. Is that isosceles? Because these two sides are the same length. Okay, good. So triangle ABD is an isosceles triangle.
And then BD.
And then the other one is what?
BD.
Okay, is BDE. Good. Whoa. All right. Good. All right, now a scalene triangle. So scalene means what? None of them are the same.
BEA.
ACB.
BEA.
Okay, triangle BEA would work. Whoops. Yep. That's scalene. I think like triangle ABC, that would be a scalene triangle. So those are some examples of that. This is a symbol for a triangle, sorry.
Oh, she was talking about the top one. Yeah.
Oh, okay. So this is basic stuff. I mean, my wife teaches 4th grade math, and I think she's told me that she teaches this stuff there. So very basic stuff. Okay. Find x and the measure of each side of this equilateral triangle. So what does equilateral mean?
I already got you. I don't even have to measure.
All of them are the same length, right? So this side, and this side are the same length.
X is, wait, what?
So all three of them are the same, so I can choose any two sides that I want to find the value of x.
Plus 9 equals 2x.
So I'm going to set x plus 9 equal to 2x. That would work. I could have put x plus 9 equals 3x minus 9. That would work also, but let's just do it like this. So take x from both sides.
X equals 9.
And so 9 here and 2x minus x is just x. So there you go. That was pretty easy. X equals 9. Now I also want to take 9 and plug it in and find out how long those sides are. So for side SR, if I plug in 9, 9 plus 9 is 18. Okay, for side RT, 2 times 9 is 18. Then for side ST, 3 times 9 minus 9 is 18. Because 3 times 9 is 27, minus 9 would be 18. Okay, example 3. So find x. All right, JM is congruent to MN. So this is an isosceles triangle. So how am I going to set this up to find the value of x?
2x
Minus 5 equals 3x.
2x minus 5 equals 3x minus 9. Okay, I'm going to take 2x from both sides. These zero out. That leaves negative 5 equal to x minus 9. Add 9 to both sides. And this is 4 equals x. If I take that 4 and plug it in, 2 times 4 minus 5 is what?
15.
3. Yep, 2 times 4 is 8, minus 5 is 3. Okay, 3 times 4 minus 9 is 3. And then just 4 minus 2 is 2.
Oh, God.
Okay, on this last one, what type of triangle is this one?
Isosceles.
Okay, this is an isosceles triangle. Okay, I know that because this side is congruent to this side. So I want to find the value of x on this one. So what do I know about those two sides right there? They're congruent to each other. So we're going to set them equal 4x squared plus x minus 14 equals 3x squared minus x plus 10. Okay, now we've got a lot of ways we can solve this. I'm going to go ahead and combine my like terms. So I'm going to take 3x squared from both sides. That way this zeroes out. And I'm just going to write this all in one step here. I'm going to add x to both sides. That way these zero out. And then I'm going to subtract 10 from both sides. That way these zero out. So that just leaves 0 on this side. And then on the left-hand side, what's left? 1x squared or just x. X plus x is what? 2x. And then negative 14 minus 10? Negative 24. Okay? So now this is going to be like stuff we were doing in our last unit. So to find the value of x, there's a lot of things I could do. I could plug that in my calculator and graph that and just see where that parabola crosses the x-axis. I'm going to do the factoring method here. So let's think of factors of negative 24 that add up to positive 2. All right.
2 or is it 2x?
So we have 124, 212, 3, 8, and 4, 6. So which one of those is going to get me to 2?
4, 6.
4 and 6. And I need the product of those two numbers to be a negative, negative 24. So one of the numbers has to be negative. Which one is it going to be?
Negative 4.
It's going to be on the 4. Because negative 4 times 6 is negative 24. But negative 4 plus 6 is my positive 2. So it's x minus 4 and x plus 6 equals 0. Now, if you remember, it's not that x equals negative 4. It's x minus 4 equals 0. So what do I have to do?
Flip it.
Change the sign. So what are my x's going to be? X equals 4 and x equals negative 6 is going to be my answer here. And remember, if you plug that in, you graph that parabola would cross the x-axis at positive 4, and it would cross it at a negative 6. All righty?
Now you think about